Good morning, everyone. Here we are on Monday morning, November 16th at 11:08 a.m. We are on our way to doing section 6.6, where we're talking about complex numbers in this section. All right, we'll start off with our first objective here, and I'll list them as we go this week. So our first objective, A, is to simplify square roots of negative numbers. So we've reached that point where we have a square root of a negative number. And what did we used to say about that is that it can't be done. There was no such number. But now we are going to introduce you to the number I. And I equals the square root of negative 1. All right, so we got to think about that. If I got I equals the square root of negative 1, then if I squared both sides, let's see if I went I squared, that's going to equal negative 1, the radicand. Just like we follow the same property as we do other numbers. Okay, doke. So I squared is going to equal negative 1, and I is going to equal that square root of negative 1. All right, so the number I, it's called the imaginary number, and it is equal to the square root of negative 1, which is the same as saying I squared equals negative 1. So we'll be going flip-flopping back and forth throughout the section here. Okay, so the way this works really is this. I can kind of show you here. So if I have, I'll get rid of this real quick. So if I have the fact that if I wanted to simplify the square root of negative 1, I could look at this and say, what is the square root? What is the square root of negative 1 times 1? I'll write it up this way. Okay, and then I could say, well, the square root of negative 1 here is I. So I could simplify this by taking the I outside, and then what's left is the square root of 1, which equals 1. So this would, in turn, would just end up equaling I for that particular problem. Then we've got several more that we can dally around with. Square roots of negative numbers are in vogue now for us. We'll be able to handle that. I suggest that you read over page 566. It'll give you a lot more in-depth information about it. Not that it goes that deeply. Not at all, really. Okay, so I'm going to give you some examples now, starting with example 1. Practice problem. So I got practice problem 1. Okay, let's do this. Let's start with, I got A, B, C, D. So A is, the problem is the square root of negative 36. And this is saying the same thing as the square root of negative 1 times 36. Okay, and looking at it this way, the square root of negative 1 is the I. So the I comes out. And then I just have left is the square root of 36, which is 6. So I'm going to write this up as 6I. Try not to write it as I6. The coefficient of I would be 6 in this case. So that would be the solution to this problem. Okay, look at B. Okay, and I've got negative on the outside, square root of negative 64. Okay, again, it's going to be negative. That's this negative just brought down. And then here I've got the square root of negative 1 times 64. The square root of negative 1 is I, so that's going to come out front. And then I've got the square root of 64, which is 8. So I could write this up as negative 8I. And we're good. How about C? C is going to be the square root of negative 18. Okay, there it is again. Hopefully you won't have to do it long. I'll keep doing it. But this is the square root of negative 1 times 18. So the square root of negative 1 is I. Bring that out front. Then I got to figure out the square root of 18. So I'll bring it over here, do my factorization, 9 times 2. Well, the square root of 9 is 3, and then 2 is left on the inside. So this would be 3i root 2. And we've got it covered that way. D. How about D? Where'd D go? Negative square root of 19. Okay. Same thing. Negative on the outside. So this is going to be the square root of negative 1 times the 19. I'll put it like that. So the square root of negative 1, again, is I. So I'm going to bring the I out front. That's going to be negative I. And then I've got left is the square root of 19. And I can't do anything with the 19, the square root of 19. I can't simplify it at all. So I'm left with negative I root 19. That's all I can do. Okay, very good. Okay, our next objective is powers of I. Objective B is powers of I, meaning if we assume that all the properties of exponents hold when the base is I, we can write any power of I as I, right? So I could write this as, if I have I raised to a power, it will equal I negative 1 negative I or 1. If I want to simplify i's raised to a power, meaning like a larger number, I raised to the 25th, what's it going to equal? It's going to equal I negative 1 negative I or 1. And that's what our next objective here is to presume. Because one thing we do know that I to the second power is going to equal what? I squared is going to equal negative 1. Because I equals the square root of negative 1. All right, that's only one little example there. All right, so let me give you an idea here. If and my way of doing this is slightly different than the textbooks, okay? I like my idea better. All right, so I'm going to tell you that if I have these are something I can write out ahead of time and keep it with me. I to the 0 power equals 1. Okay, remember that from beginning algebra. Anything raised to the 0 power equals 1. Well, I to the 0 equals 1. All right, then I'm going to have I to the first power. Well, that must just equal I. I squared is going to equal, what did we say that was just a moment ago? Negative 1. And then let's do one more. I cubed. What is that going to be? Well, if I squared equals negative 1, then it's going to be, let's see, I'll do it this way. I times I times I to the third. So I times I is I squared, and I squared equals negative 1. Okay, and then times that by this I. This is just going to come down now. Oh, my arrow's not very good. It's just, I'm bringing it down. So it's negative 1 times I equals negative I. So there, I think I've got it. I've got 1, I, negative 1, and negative I. And just like I said up here. 1, I, negative 1, and negative I. So I've got them all accounted for. And what I want to emphasize are the what I'm starting off with. I to the 0, and it goes up to I to the cube. I to the third. Okay, so I want to write this down or have this handy when I'm determining the simplification of some of these problems. Well, and let's see what we have here. I've got, I could pick anything. Let's do example 2. Or how about practice problem 2? It's saying what is, so here I got practice problem 2. And the problem is, I got A, B, and C here. So A is going to be I to the 20th, and we've got to simplify that. Okay, if I simplify that, what I want to do is I want to divide the exponent, the 20, by 4. And the 4 comes from I to the 0, I to the 1, I to the 2, I to the 3. There are 4 answers here that I'm looking for. So I'm going to take the 20, divide it by 4. And then that's going to give me, well, I want to do the division here now. I want to divide 4 goes into 20. All right, if I go 4 goes into 20, then that goes 5 times. And 5 times 4 is 20. I subtract and I have a 0 remainder. Okay, so because I'm looking at the 0 as the remainder, that's going to match this number here, that exponent, which is 0. And therefore, I to the 20 is going to equal 1. So I to the 20 equals 1. I'm dividing the exponent by 4, and then I'm determining, after I do the division, the long division, what's the remainder? And the remainder is this number here, and that's going to be the exponent that I'm going to use in this list here. Let me change that color. Where'd my red go? So this is my list here that I'm going to match it up with, and then I get the resulting answer. All right, so let me move on here. Hold on. Okay, so this next problem is I to the 23rd. Okay, I want to take with me I to the 0, I to the 1st, I to the 2nd, I to the 3rd. Only go up to I to the 3rd. Okay, let's keep these what they equal. I to the 0 is 1. I to the 1st is I. I squared is negative 1. And I to the 3rd is negative I. Okay, so memorize this and just write it down, every problem you get. All right, so now I want to take the 23, divide it by 4. 4 goes into 23. Let's see, 5, not 6 times, but 5 times. 5 times 4 is 20. I subtract. I got a 3 remainder. Now I want to look at what is I to the 3rd power. And I to the 3rd power equals negative I. So I to the 23rd equals negative I. Isn't that sweet? Very sweet. I like that. All right, next, I got one more here, which is I to the 50th. All right, how about it? This is C, and my problem's going to be I to the 50th. Okay, I'm not going to rewrite it down there, but I know I'm going to take the 50 because we're simplifying these, what powers of I is what we're simplifying. So I got 50, and it's going to be divided by 4. 4 goes into 50, 10, 11, 12 times. 12 times 4 is 48. Subtract, I got 2 remainder. So what is I squared? I squared equals, I'll look up here, I squared equals -1. And we're good. All right, so remember that procedure when you're doing it, what you're going to need to do. And that is memorize this or write it down for each of the problems, and then divide your exponent by 4. And then you don't want the answer to compare it to, you want the remainder. And the remainder will be either 0, 1, 2, or 3. And match it up and you're good to go. All right, our next task here is to, I got a definition about a complex number. A complex number can be written in the form. Complex number is written in the form A plus BI. We're going to have to write our answers in A plus BI form. All right, what it says. A and B are real numbers, and I equals the square root of -1. So the form A plus BI is called standard form for the complex numbers. The A, this part here, is the real part of the complex number. The number B is called the imaginary part. So you have a multiplier that you'll multiply to I, and this will still remain as the imaginary part. And you'll want to know more about that when you are graphing complex numbers. And we're not quite there yet with that. That comes with college algebra. Okay? All right, so let's see what we've got to do for now. Where am I here? How about, oops. And then they give us a nice chart here for that as well on page 568. Oh, hold on a second. Okay, then for what we're going to talk about next is our objective C, which is the, let me write it out here for us, the equality for complex numbers. I'll do it here. What does that mean, equality for complex numbers? Well, I'm going to write out our equations or our expressions and get them in next to each other. So it would be A plus BI, and that's to emphasize what we're talking about here. A plus BI will equal C plus DI. If and only if A equals C and B equals D. Okay, and notice how they're paired up. A equals C, this is the real part, and then BI, oh, that's an indication it's the imaginary part, and B and D are the imaginary parts. So I could set this up and get this equal to each other, where A equals C and B equals D. And that's what I'm going to do with our first example. All right, so I'm going to write up something here, and let's make it the practice problem. Practice problem 3. Actually, I think I'm going to switch over. I'm going to switch over to the example, and then I'd like you maybe to practice the practice problems. That way it's not real evident. The answer is down at the bottom, but it's easier for you to cover that up and see if you're doing that right. So let me go with the example 3. Example 3. And that problem is find X and Y and Y if 3X what is that, 3x plus 4i equals 12 minus 8yi. Make sure I got that right. Okay, so what we want to do, and this is very simple once you understand what we have to do here, I want to pair the real part of the expressions to the imaginary part. So what I mean by that is I'm going to write this up as 3x equals 12. Okay, that's the real part. Then I'm going to pair up the imaginary part, and that's going to be 4 equals negative 8y. And notice I'm leaving the I out. If I left the i's in, they just cancel out anyway, but we want the imaginary part. And this is what it's going to look like. And now, what was my order to do? Find x and y. So x, I'm going to divide both sides by 3. So x equals 4 here. Okay, and this one I'll divide both sides by negative 8. And y will equal negative 1 over 2. 4 over 8 is the same as 1 over 2. Remember to always simplify your fractions. All right? Okay, very good. Let's try another one. Let's try example 4. Okay, here it is. And how about it? So now I've got the real part and the imaginary part. Here's my real part, 4x minus 3 in parentheses. So it's telling you that's all the real part. And I'm going to pair it up with this equaling 5. Okay, once I get that, then I'll take a stroll over here and take the 7 and get that equal to 2y minus 1. Again, I'm leaving the i's out of the equation. All right, so there we are. Let's try it. So I got 4x minus 3 equals 5. Okay, if I finish this off, how about I add 3 to both sides? 4x equals 8. So therefore, that's what the 3 dots mean, by the way. Therefore, x is going to equal 2. Okay, I'll move over now and let's do the imaginary part. And that's going to look like 7 equals 2y minus 1. And I'm going to solve for y. So let's add 1 to both sides. I got 8 equals 2y. Divide both sides by 2. So y is going to equal 4. And those are our solutions that we're looking for, because the same directive was given to us to find x and y under these conditions. And we did it. Very good. Next problem. All right, here we're on to objective D. We're going to add and subtract these complex numbers. Very, quite simple, really. All right, and here's how this will work. I'm going to write up a couple of expressions here, and let's say we're going to have a plus bi plus, and I'll write the second one up as c plus di. And this is, quite frankly, the same as doing the polynomials when we're adding and subtracting polynomials. Okay, so this is what will happen. I'm going to have a plus bi plus c plus di. Well, this is an addition sign here, so the parentheses are just going to drop out, because there's going to be no change to that, as opposed to if that was a subtraction sign. So when I'm adding them, the parentheses just drop out, and you're going to add together the real parts, and then you're going to add up the imaginary parts. Okay, oh, I use the same color. All right, so this means what? This will be A plus C plus B plus D, or I could say BI plus DI is okay to write it up that way. I'm adding these up together, and whatever that comes to, it comes to. All right, but my final answer will be written in A plus BI form, the, what do we call that? The standard form. So that's a given. That's a must that we have to do. All right, let's do some examples here. I'm on example 5. I'll stick with the examples for no reason. All right, and what have I got here? I've got 3 plus 4i. Hope you don't mind my eyes being like almost a C. And then I'm going to add 7 minus 6i. Okay. And I suppose that's going to be it. Remember, these drop out, and then I just want to line these up in, what would you call them, like columns, where I'm going to add and subtract the like terms. So the 3, if I can get rid of the parentheses, I will. It'll be 3 plus 4i, and then plus 7 minus 6i. Get rid of the parentheses. All right, then I'm just going to add my like terms. So that would be what? 3 plus 7 is 10. And then I've got 4i minus 6i is negative 2i. And that's my answer, 10 minus 2i. And it's written in A plus BI form. So we got it. All right, that was A. And let's go ahead and do B in the example. B. I'm going to write it up first. Okay, how's this? So now this time I have a subtraction sign. So I've got to subtract these two complex numbers. So I want to address that first. Okay, and here's how I'm going to do it. I'm going to put my negative 1 here. And then I'm going to go ahead and distribute the negative 1. Negative 1 times 5 is negative 5. I'll put my negative 5 underneath the 7 over in this column here. And then I'm going to have negative 1 times 6i, which is negative 6i, and that'll go in the I column, negative 6i. And then I'll simply combine my like terms. 7 minus 5 is 2. 3i minus 6i is minus 3i. 2 minus 3i is my solution. Try C. Okay, here's another one. And again, note, it's a subtraction problem. So I can't just drop off my parentheses and start combining. I have to distribute the negative 1. Put it there and do the distribution. And put your answer for each component underneath the like term in the first parentheses. Negative 1 times 9, negative 9. Negative 1 times negative 4i, positive 4i. Draw a line, combine. 5 minus 9, negative 4. Negative 2i plus 4i is positive 2i. And there you go. Fairly easy. I hope you agree with me. Okay, let's continue on. And here it is, objective E. How many objectives were there? All right, multiply complex numbers. Now we're going to multiply them. And it really kind of looks like we're going to be doing the FOIL method here. I'm just going to FOIL these. Okay, so let's scoot that up. And where am I? Example 6, where I've got 3 minus 4i. And that's going to be multiplied to 2 plus 5i. All right, we're going to FOIL these, and we also have to remember that I squared equals -1. Okay, all right, so let's just FOIL it. I got my F first is 3 times 2, which is 6. Then I can do the outside, which is 3 times 5i, which gives me positive 15i. Inside, I've got negative 4i times 2, which is negative 8i. And last, I've got negative 4i times 5i. Ooh, let's try that. It's going to be negative 20, and then I times I is I squared. Negative 20i squared. Okay, and there's the part I mentioned, but I squared equals -1. So I'm going to rewrite this. So I've got 6, 15i minus 8i is positive 7i. And now that's going to be minus 20, but I squared is -1. This is the breakdown of it. All right, so what changes here? 6 plus 7i plus 20 is going to equal 6 and 20 is 26 plus 7i. And that's the additional work you have to do. You have to think about that, because this ended up losing the variable, which we're calling I. Not really a variable even, but we changed that I squared to the -1. Then we're able to multiply those two numbers to give us another number that we have to add to the real part at the very beginning. That's 6 in this case. So just a little extension of what we already know. Okay, that was whatever one. That was example 6. So let's see, we got different variations of multiplying. So example 7 is going to be what? Example 7, 2i times 4 minus 6i. Okay, 2i times 4 is 8i. 2i times -6i is -12i squared. And the I squared is -1, so how is this going to change? It's going to be, I'll write it up this way first. How about 8i and then -1, I'll write it up this way, -12 times -1, because that's what I squared is -1. So this will be positive 12. Okay. Do you see the problem in my solution here? Yes, it's not in standard form. I have to write it in standard form, so I'm going to flip these around, and my answer will end up being 12 plus 8i. And now we're good to go. Okay, number 8, example 8. Okay, here I have my binomial squared, so that means what? It's 2 3 plus 5i's. So I'll write this up twice. 3 plus 5i times 3 plus 5i. And then I'll FOIL it. 3 times 3 is 9. 3 times 5i is 15i. 5i times 3 is another 15i. And then 5 times 5 is 25. And then I times I is I squared, which is -1. So this ends up being -25. And then I've got 9 minus 25. And that's -16. My two middle terms here, they add up to be 30i. So I got 9 minus 25 is -16 plus the 30i. How's that look? Okay, and choose your own way of doing that if you have a nicer flow to the way you do it. Remember, it's all about you, really, and how you ascertain these numbers and how you calculate them, what order you do. And nothing is wrong, unless your answer is wrong. But you know what I mean. The method is not wrong, as long as you're accomplishing the same goal. Let's do example 9. Okay, here's 2 minus 3i times 2 plus 3i. Here's where we're multiplying the sum and the difference of the same two terms. Okay, when you catch that, there's a huge shortcut for it, but we're not going to worry about that now when we're dealing with the complex numbers. Let's just do like do as they're asking without shortcuts and the like. I could have taken the shortcut up here with that binomial squared. Square the first term, square the second term, and then multiply the 3 terms for so it equals the middle term. Look at here. If I do in the middle term, 2 times 5 is 10 times 3. 30 times I is 30i. Okay, square the first term here, square the second term here. And that was with that -1 as well. So you could do it as that way as well. But let's not worry about it right now. Like for this one. I just want to FOIL it. 2 times 2 is 4. 2 times 3i is positive 6i. Look at the inside. 2 times -3i is -6i. And last is going to be -3i times 3i is -9i squared. But again, we know I squared is -1, so -1 times -9 is positive 9. That I can add to that 4. And if I add that to the 4, it gives me 13. And then the imaginary part, well, those canceled out. I've got 6i minus 6i. These cancel out. They subtract each other, so I'm just left with the answer of 13. When you have the sum and the difference of the same two terms, that is what happens. And if you don't catch it, it's not a big deal at all. By the way, if they wanted you to write, I guess, that's a great question. If I wrote that as, this is okay for my answer, but that's the real part, 13. If I wanted to write it in complex form, it would be 13 plus what? So it's in the complex form that you're stating. I could write it alternatively as 13 plus 0i. But 0 times I is 0, so, it doesn't really matter in this case here. Just an alternative way of writing that in complex form. All right, move on here. All right, how about objective F? This is our last objective. Division of complex numbers. Okay, let's do a couple examples of division. And you've already done this before. What we're really dealing with here is the i's, especially that I squared, because it equals -1. Okay, so let's try it. Here I've got example, what is this? Example 10. And how about 2 plus I? And that's going to be over 3 minus 2i. All right, so what we're going to deal with here, if I've got a fraction with complex numbers, I want to multiply top and bottom by the conjugate of the denominator. And the conjugate, we remember, is going to be 3 plus 2i. When I do the bottom, I do the top. 3 plus 2i. Okay. And that nice thing that happens when I multiply the conjugate is I've got the sum and the difference of the same two terms again. So that means my middle term is going to be non-extinct, non-appearance, not going to appear here. All right, so if I multiply these denominators, I'm going to FOIL that. So I got 3 times 3 is 9. 3 times 2i is positive 6i. Inside is negative 6i. And then negative 2i times 2i is going to be negative 4i squared. And then again, we note that negative 4 times negative 1, because that's what I squared is going to equal positive 4. And then I'm going to end up adding the 4 to the 9 over here. And 4 and 9 is going to give me 13. Yes. Okay, so I got 9 and 4. Then, going on, I've got positive 6i minus 6i, so I have 13 in the denominator. Remember, that's what I was doing here, and 13 is going to go here. Now I'm going to do the numerators here. Let's see if I can squeeze it in here. 2 times 3 is 6. And I guess I'll come down here. So 2 times 3 is 6. I'm going to FOIL this now. Outside is going to be 2 times 2i, which is 4i. Move that up a little bit. Inside is 3 times I, so that's positive 3i. And last I've got is I times 2i, which is going to be positive 2i squared. Then I squared is the negative 1, so it's negative 1 times 2 is negative 2. So that makes my complex number to be 6 minus 2 is 4 plus 7i. All right, and if I wrote that up here, 4 plus 7i, and there's just a minor problem with the way I'm writing this answer. 4 plus 7i over 13 is not written in the a plus bi form. All right, so I have to rewrite that with the 13 under each of the terms in the numerator. So all this matters is that it's going to look like, let me come over here. I'm going to have 4 over 13, which is the real part, plus 7i over 13. And there's the answer in complex form. The real part, the imaginary part. Okay, we got one more here. Example 11, slightly different. And this one's going to be 7 minus 4i. That's going to be divided over I. All right, so what we've got to do now here is we got to multiply by the conjugate of this denominator. And if this denominator is just a single term as it is, then the conjugate of I is going to be negative I. All right, and that's top and bottom. Negative I over negative I. All right, so let's see what happens. I'll do the numerator first. All right, so that means I'm going to distribute the negative I over the 7 minus 4I, and that's going to give me, well, let's see if I can do it down here. That's going to give me negative I times 7 is negative 7I, and negative I times negative 4I is going to be positive 4I squared. And then, what do I know? I know I squared is negative 1, so it's going to be negative 4. Negative 1 times 4 is negative 4. So I'm going to write this up as negative 4 minus 7I. And that's your numerator. And down below that, here I got negative I times I. Well, that's negative I squared. Oh, I didn't want to do that. I'll put my answer there. I'll do it out here. I've got I times negative I is negative I squared. But I'm saying I squared is negative 1. So this looks like it's going to be negative 1, which is positive 1. Which I don't have to write that because it just simplifies to be this. And you don't need it to be over a 1. Okay, that looks like it for today. And I can get into it. It was fun. All right, so that's it for now, and we will say have a good day today. Talk to you on Wednesday, and then our next test will be on Monday over Chapter 6. So we're coming along. After Monday, we got one more chapter to go. Excellent. All right, take care. Have a good day.